All right. Hi, guys. I'm not here today. So what I'd like you to do right now is just take out your textbooks, open them up to section 4 or 3.4.1, and I'd like you to do this warm up that you see here. So I want you to solve the following equation using the quadratic formula. So if you don't remember what the quadratic formula is, it's that song that I used to sing. Um, and hopefully you've memorized it. If not, I'm going to write it up on the board. So here we go. So we got x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. All right. So what I'd like you to do is pause the video, and I want you to do this warm up trying to find and solve this using the quadratic formula. Go. All right. So what I'm going to do is I'm going to show you the answer. Here's the answer right here. It's x equals 11 plus or minus I root 407 over 8. If you left the negative, if you left it as the square root of negative 407, technically you're right, but we want to actually start getting into the habit of you pulling that negative one out as I. So if you did that, and you have this, go on to the next thing. If you're like, yeah, I had no idea what you did, let's pay attention really quickly, all right? So here we go. We have standard form. We're going to use the quadratic formula. So I like to list out A, which is 4, B is negative 11, and C is 33. So when we do this, we're going to go x equals negative B, so it's positive 11 plus or minus the square root of B squared. So it's negative 11 squared minus 4 times A, which is 4, times C, which is 33. Make sure you extend that square root all over 2a, so 2 times 4. All right, so now all we're going to do is we're going to simplify two things. We're going to simplify underneath the square root into a number, and we're going to simplify 2 times 4, which is 8. Well, okay. So now you're just going to type this in, making sure you put the negative 11 squared inside parentheses, minus 4 times 33, and you should get negative 407. Now we want to simplify this a little further and simplify the negative inside the parentheses to be x equals 11 plus or minus I root 407 over 8. And that's what we want to start doing today, because we are going to be talking about complex factors, all right? And remember, when we solve using quadratic formula, what we're actually finding are the x-intercepts, all right? You're finding the x-intercepts today. So that's going to be the big thing, you being able to do that, all right? So let's go to the next page, right? So today you're going to factor polynomial identities over complex numbers. So we're going to be talking about complex numbers again. So we're going to need to remember what complex numbers are, know what an identity is, and know what complex conjugates are. So those are the things we're going to be talking about today. I'm going to be talking really quickly, so if you're like, yeah, I didn't get that, pause it, go back, replay it. All right, the nice thing about this video is you can hear it over and over and over again. All right, here we go. So let me kind of block this off for you really quickly. All right, I want you to take these notes here, okay? So remember, a complex number is written in the form a plus bi, and that means that you have two parts. The a part is your real part, and the bi is a coefficient times I, your imaginary number. You always put the real first, then the imaginary number. So for instance, you could have 3 plus 4i, and that right there is complex. The 3 is real, and the 4i is the imaginary part. Now, one last thing we need to remember is what I squared equals. Remember, I to the second power is negative 1. Remember, I to the first power is actually the square root of negative 1. All right? So we never want to have the square root of a negative number. We always want to pull that out as I, and that's a very, very important key that's going to help you out here. So let's take a look here. So example number 1 on page 131. Sorry if I didn't say that. Take out page 131. All right, flip to it. And what we're going to do is we're going to simplify each of these expressions. There are two expressions here, all right? We're going to do one at a time. I don't know why the book does it like this, but we're going to start with this one, all right? And that's where number 1 starts. So what we're going to do is we're going to combine like terms and simplify this expression. So this is kind of like a review. So if it's a review, awesome. If it's not, well, take some notes, pay attention, all right? So when we have this add to simplify, the first thing I like to do is get rid of the parentheses, and that means we're going to distribute what's out in front. Both of them, there's a positive one, so we're really just going to rewrite it without parentheses. 3 plus 2i plus negative 8 plus I. Now, remember, I is a number, but I acts like a variable. So what we're going to do is we're going to combine like terms with our real numbers, so 3 and negative 8, and we get negative 5. And then we're going to take our imaginary numbers, 2i and I, or 1i, and that's going to give you 3i. And this is written in complex form and simplified complex form. So that's how you do number 1. Now number 2, All right, this says multiply. So number 2, here we go, multiply these two. So it's the second problem in there. All right, not the same problem. The first problem asks you to add. So this problem you're going to multiply. So we multiply just like we would with the binomial. We're going to double distribute x times x, which is x squared, x times negative 3i, which is negative 3ix, positive 3i times x is positive 3ix, and then 3i times negative 3i. So when you do that, 3i times negative 3i, let's start with the 3. Is 3 plus 3 times negative 3 is negative 9. I times I is I squared, like you would multiply x times x. So this right here, we have to combine and simplify some like terms. Here, let's combine our 3i's and x's, the ix terms, right? Well, negative 3ix, positive 3ix, those cancel out. So your x squared is just going to come down. That has nothing to do with anything here. But we actually can simplify negative 9i squared before we bring that down. Remember, I squared equals what? Oh yeah, it's negative 1. So we actually are going to go negative 9 times negative 1. We're replacing I squared with negative 1. And that's going to give us plus 9. So this right here is your final answer, x squared plus 9. So it started off as a complex number, and it ended up being non-complex, or what we call real. So that's what we're going to be doing. And actually, we're going to kind of be doing the reverse of this. We're going to start today writing equations. We're going to start in this form, and then we're actually going to go back and write it into complex binomials. It sounds confusing, but actually it's very simple. So let's go to the next problem. So on this page, all right, on page 32, we have, or 132, again, I have some notes that I want you to put up here, okay? So here's your notes. It's a squared plus b squared equals your two binomials, a plus bi times a minus bi. Now, today, what we're going to be dealing with is this a squared is actually going to be like x squared. All right, it's going to be x squared. So in our problems, in our binomials, it's going to be x plus something and x minus something. And these somethings, this number that you're going to be looking for, this bi or this imaginary number, we're actually going to find what that value is by finding our x-intercepts, either by taking the quadratic formula or by solving by taking square roots. So, all right, we're going to be starting off, in a kind of maybe a standard form or as a binomial or trinomial, but we're going to end up today kind of factoring it into two complex binomials. So let's get started here, all right? So here we go. All right, example number 2. You got to love example number 2 because they put two problems in one very little space. So we're going to do two problems at one time. We're going to start with the top one. We're going to start with 9c squared plus 100. So what we're going to do is we're going to use zeros of the following quadratics to write the quadratics in factor form. So we're not going to follow directions of what it says for there. Same with your homework. What we're going to do is we are going to rewrite this using zeros. So we first need to find our zeros or our x-intercepts. And how we do that is we go 9c squared plus 100. And to find your zeros, your x-intercepts, when written like this, we set it equal to 0. You set this value equal to 0. You set the y equal to 0. So now what we're going to do is we're going to solve for c, or our x, or our variable in this problem. So we're going to solve for this, which is going to give us our x-intercept, but we have to continue to solve. So 9c squared equals, so 0 minus 100 is negative 100. We divide by 9. Now, here's the thing. Negative 100 divided by 9 is not going to simplify nicely, so just leave it there for a second, because what's going to end up happening is we're going to get c squared equals negative 100 over 9, and how do we undo squaring something? We square root it. Now, here we go. We all know, as you should have done on your test yesterday or your quiz yesterday, when you take the square root, you actually get two answers here. We're going to get two answers. We're going to get c equals plus or minus. Now here's the thing, because we have a fraction getting the square root taken of it, we're actually going to take the square root of each individual part. So the square root of the numerator over the square root of the denominator. Well, your denominator is going to be 3. Your numerator, the square root of negative 100, well, the negative is I. The square root of 100 is 10, so it's going to be 10i. So these are your two x-intercepts. You see here? So we got c equals plus or minus 10i over 3. So what we're going to do is we're going to rewrite this, okay, as two binomials, right? As like two x-intercepts in intercept form. So watch what we're going to do. So we're going to rewrite this as, ready? So I said before x, but really it's c, so we're going to have to go here. Ready? C plus 10I over 3 and c minus 10I over 3. So that is your original problem that's right here that I just starred. That is that factored out. All right, that problem cannot be factored out without using complex numbers or imaginary numbers. So that's how you write it. So you put your variable plus or minus your 2x-intercepts. So that's what we're going to be doing today. So I'm going to go through the next one really quick. All right, so you can see this next one. So again, you set this equal to 0. So we're going to go 12 plus 75y squared equals 0. Subtract 12, subtract 12. So we're going to get 75y squared equals negative 12. Divide by 75, and you get y squared equals negative 12 over 75. I'm not going to simplify that because I'm taking the square root. Now, neither of these will simplify nicely, so watch what happens. My answer is going to be y equals plus or minus. Now, here's the thing. All right, I can't simplify 12 or 75, but I can simplify the negative, so it's going to be I root 12 over 75. So you ready to see how this thing's going to look when we write it as two binomials? We write it as y plus I root 75 over 12 and y minus I root. Now I got to get rid of all this stuff. Sorry about that. I didn't space that out nicely. I root 75 over 12. So literally, you're finding your x-intercepts, and then you put them back into intercept form. So you're basically rewriting this problem from standard form to intercept form. So that's what you're doing there. I'm not going to do example 3 because example 3 literally is the same thing, but I want to quickly show you. Actually, you know what? I will show you example 3. So this example 3, again, we're going to rewrite this using the zeros. So we have to find the zero. So we're going to go x squared plus 3 equals 0. So we're going to set this thing equal to 0, and we're going to find our x-intercepts by subtracting 3. So we get x squared equals negative 3, and then we take the square root, and you're going to get x, no, I was about to write squared, but it's x equals plus or minus. Now, here's the thing. Negative 3 is not going to simplify. 3 won't simplify, but the negative will. It's going to be I root 3. So these are your two x-intercepts, and we're going to write this as a binomial x plus I root 3 and x minus I root 3. All right, that's all you're doing. You take your variable, whatever the x-intercept variable they choose to use in the problem is, that plus or minus your two solved for x-intercepts. So that's when it's nice and easy, when you can solve by taking square roots. But take a look at your last problem that you're going to be doing before you do your homework or replay this over and over again. This is written out as a trinomial. This you cannot solve by taking square roots. I repeat, you cannot solve this by taking square roots. This you are going to have to solve. So you're going to set it up, 3x squared plus 2x plus 11 equals 0. You're going to have to use our best friend in the entire world, the quadratic formula, which again is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So here we go. Our a is 2, our b, our a is 3, our b is 2, and our c is 11. So now we will start the quadratic formula. We will start our work as x equals the opposite of b, which is going to be negative 2 plus or minus the square root of b squared. So b is 2 squared minus 4 times a, which is 3, times c, which is 11, all over 2a, so it's 2 times 3. So again, all we're going to do is just simplify the number underneath our square root and our denominator, 2 times 3, which is 6. So here we go. You can take your calculator, or you can try to do this in your head. I'm going to try to do this in my head. So we're going to go 2 squared, which is 4. 4 minus 4 times 3 times 11. So you are going to multiply those all together, and you should end up getting 16 minus, oh man, let me get this, So 16 minus 132, and you should get negative 116. Negative 116 here. All right, now 116 cannot simplify, but the negative underneath there can. So what we're going to do is we're going to simplify this as negative 2 plus or minus I root 116 over 6. These are your two x-intercepts. Those are them. Those are your two x-intercepts there. As scary looking as they are, you technically are almost done. We're going to rewrite this though as a binomial. So we're going to write it as x plus something and x minus something. Well, what are those somethings? Those somethings are this answer. So you're going to write out negative 2 plus I root 116 over 6. And then you write negative 2 minus I root 116 over 6. And this, ladies and gentlemen, is your final answer. You have just written two complex values, two complex binomials that once were that trinomial that started out problem number 4. All right. So if you had no idea what was going on, replay this video. Try the homework. The homework tonight is page 135, 1 through 7. Please be good to the sub. Please make sure you're doing your homework. If you don't understand what's going on, come and see me tomorrow morning. We will be doing this again tomorrow, but make sure that you're trying this, attempting it, so you have questions, so you know where you had some pitfalls, so we can get right back at it tomorrow, okay? Thank you. Have a great day. All right. Again, if I haven't said this enough, please be good to the sub. Take care.